Good evening. I am here to present my CLC6 over Dijkstra, I think is how you say it, Dijkstra's algorithm. So let's get to it. So Dijkstra's algorithm is an algorithm that searches for the shortest point in a graph, the shortest path from one node to another in a graph, by systematically selecting the nearest vertex not yet processed and performing a relaxation step to update the neighboring vertices with the shortest path to them. So it's a recursive algorithm, like all the good ones. So first the instructions wanted us to start at Greenlee, and Dijkstra's algorithm, you need to set it to 0, and all of the other nodes to infinity. So from here, you're going to go and find the shortest path. The shortest path for now, we can see, would probably be Graham. So it's going to update their distances from Greenlee if it's shorter than what's currently recorded, which means it's going to update these. So like this is 0 for Greenlee, and then here would be the shortest one, so it would be 1 for Graham. And then it would continue on its merry way until it finds the shortest possible path. So as it says, it's going to choose the node with the smallest tentative distance, which is tentative is the important word here because this is not actually the correct path. I ran the Dijkstra's algorithm on it just to see what it would be. I'll show that to you in a second. But for now, it looks like Graham is going to be the shortest route. And then it continues onward. So it turned this into 1. Well, it turns it into 0. They all go to 0. It's like, oh, check, visited that one, go to 0, find them all. Oh, okay, that's the next one. So the algorithm is going to proceed all the way until it gets all the way down here. I didn't animate all of that because it was taking a long time. But when I ran it, the algorithm came up with this path to being the shortest. Greenlee is actually 4. I left the original numbers in here because it's easier to find, the nodes, because this is what we want to see. We don't want to change all of our nodes all the time. So this is apparently the shortest path. And I can show that to you right here with Dijkstra's algorithm. The beautiful thing about these named algorithms is they're really easy to find on the internet. So you can go and you can find it and you can play with it and edit it, obviously, to whatever your heart desires. So when we run this, it just tells us exactly what I have as a screenshot, and it tells us that the shortest path is from Greenlee to La Paz is via these nodes. So there we go.